So hello everyone, welcome. So in the last class we started with the chapter that was our reaction mechanism. In the first class we have seen about the basic things, that was about the substrate, reagent, nucleophile, electrophile, how the interactions were taking place between a reagent and a substrate based upon the MOT approach also, that we have seen in the last class. So today we are starting with our next topic, which is our nucleophilic substitution on our saturated carbon atoms. So what is meant by the nucleophilic substitution? It means that our reagents nucleophilic part will be attacking over the substrate, right? And the substitution means that your one of the chemical species, suppose we are taking an alkyl halide, so the X, that is, suppose X is a leaving group over there, such as OTF, OMS, such groups can be there, and that group is leaving and some nucleophilic part is attacking over there. So that leaving group is being substituted by your nucleophile now. So the reaction will be called as substitution, right? And here nucleophile is attacking and that is substituting that X negative group. So the reaction becomes a nucleophilic substitution, right? So what is meant by the nucleophile? Nucleophile, we have seen that it is a nucleus loving species, right? So nucleus, since it carries a positive charge, so the species that will be attracted towards it will be your electron rich in nature, right? And next is about the saturated carbon that we are going to focus today. So saturated carbon means the carbon center at which the attack of the nucleophile is going to take place is your saturated, means it is your sp3 carbon center, right? So now, so let in this nucleophilic substitution we have various types of the categories of the reactions that we have to see, which can be broadly categorized as your SN1 reactions. We will be seeing your SN2 is there, and we have SNI reactions, and we have your SNGP is there, and along with this we have is our SN2I is there, SN2 dash, or it is called SN2 prime is called. Okay, so all of this we have to see. So for the while we are going to focus on our SN2 reactions. Okay, so before starting this, let us see a general scheme about the reaction that occurs at any carbon center. So suppose, let me consider the alkyl halide. So Rx is your alkyl halide. There will be other substituents also, like your epoxide, ethers, all that also we will be considering, but for the meanwhile we are looking only upon the alkyl halides, right? So now this alkyl halide, suppose we are adding any polar solvent to it, polar solvent. So we know that the solvents are used to bring the homogeneity in the solutions and to bring the proximity between your reagents and your substrate, right? And generally we make use of the polar solvents because the ionic species are involved. So here I have written the polar solvent, right? So alkyl halide, it means that the bond is present between our carbon center and an halogen, right? So that means we are having as a CX bond, right? So since no bond is perfectly ionic, neither it is purely covalent, so there is possibility that one of the two is going to be the major one. So suppose if we have the more amount of your percentage ionic character in your carbon halogen bond, so in this case we are going to get as a formation of the R positive in between the solvent is there and the X negative. So what it is called? This is called as your intimate ion pair. It is called your intimate ion pair. So when the percentage ionic character is more, we get as the formation of the intimate ion pairs, which on further solvation is going to give you the carbocations, that will be R positive plus the X negative. And such type of the mechanism, it is generally seen in the cases where your SN1 reactions are taking place. Okay, and the other possibility is when your carbon and the halogen bond is there. So in this, if your percentage covalent character is more, so in this case we get is the formation of Rx bond with the partial signs over it. That is your delta positive and delta negative. So here this type of the mechanism is generally seen for the SN2 reactions. So that means we are going to see the SN2 path firstly. So that means my carbon and the halogen bond that is present, it is having a covalent character. So we are going to focus now only on this path where your SN2 path is followed. Okay, so what happens in your SN2 reaction? So this you might have learned in your lower classes that it is called nucleophilic substitution reactions of the second order. But why is it called so? That also we will be seeing. What is the general mechanism that how the reaction is occurring place? So for that, let us consider a substrate that is a carbon. Let me draw it on the other side so that nucleophile can also be drawn over here. So carbon center is there and it is having one living group, that is X. It is a good living group such as your halogens, it can be there, or it can be your OTS, OTM, OTF and OBS, OMS, that living groups might be there. So along with that we have the substituents, that is your R1, R2, that is at the wedge position, and the R3 it is there. So this carbon center, it is forming four of the sigma bonds that we can see. So now what is happening? So the nucleophile is going to come and attack over the sigma star, that is of your carbon and the halogen. Why is it attacking over the carbon and the halogen? That we have seen in the last class. Since your sigma X bond of your carbon and